Okay, let us now solve question number 28. Question number 28 says the lower window of a house is at a height of 2 meters above the ground and its upper window is 4 meter vertically above the lower window. At certain instant, the angles of elevation of a balloon from these windows are observed to be 60 degrees and 30 degrees respectively. Find the height of the balloon above the ground. Okay, so let us try to understand the question line by line. It says the lower window of a house is at a height of 2 meter above the ground. So it means there is a house. So for that I need to draw a horizontal line, a horizontal ground. Let us say this is the horizontal ground. On this ground there is a house and the lower window of this house is, let us say, situated at this A point and this is the foot of this window which is B point. So this lower window is 2 meters above the ground level. It is 2 meters above the ground level. Further it says and its upper window is 4 meter vertically above the lower window. So the upper window is 4 meter vertically above the lower window. So what the 4 meter is? 4 meter distance is calculated from this lower window, not from the ground. So it means I need to move 4 meter upwards like this at somewhere this point, which is, let us say, C, where the upper window is situated. So this distance is given as 4 meters, this particular distance. So what is the overall height of this upper window from the ground level? I can see the overall height of this upper window from the ground level is 4 plus 2, that is 6 meters. Okay, this is 6 meters. So this is what we can conclude till now. Now further, at certain instant, the angles of elevation of a balloon from these windows are observed to be. So what does this mean? That there is a balloon and I am observing that balloon from these two different windows. There are two persons standing on these windows, one is at C and one is at A, and both are observing a balloon. Okay. Now mind it, it says that angles of elevation. It means if I am observing the balloon from this A window, then the balloon is above the level of this A window. But where? If the balloon is above this A level, then where the balloon is exactly situated? It may be located in between this A and C, it may be located above C. Okay. So there are two positions that the balloon can have. Lekin further it said that the angles of elevation, it means if I am observing the balloon from this A point or A window, then also I need to move my head upwards. And if I am observing the same balloon from this C window also, then also I need to move my head upwards. It means what? It means the balloon is above the horizontal level of this C window. So definitely balloon is somewhere here. Okay, why it is so? Because to observe this balloon from C window also I need to move my head upwards, not downwards. It do not say that angle of depression from this upper window. It clearly says angle of elevation. It means the balloon is above the level of this upper window. So I assume that, let us say the balloon is located here. Let us say this is the point D. This D point represents the balloon. So if I am observing this D point from this C point, what should be my line of sight? My line of sight is this one. Okay, this is my line of sight. And if I am observing this balloon from this lower window, my line of sight will be this one. Okay, this is my line of sight, and this D when projected to ground, let us say this is point E, where DE represents the height of the balloon, the altitude of the balloon. Okay. Now similarly, as I have drawn a horizontal line from this C point, I can draw a horizontal line from this A point also, like this, because this line shows the level of the A point. Okay. If there is an object on this line, then there will not be any angle of elevation or any angle of depression, because to observe an object which is located on this line, I need not move my head upwards or downwards. That's why for this A point, this is the horizontal line. Now let us say this horizontal line intersects this DE at some point F, and the line drawn from this C intersects this DE at some point G. Okay, like this. Now what is the angle of elevations given? The two angles of elevations are given as 60 degree and 30 degree. Now which angle will be 30 degree and which angle will be 60 degree? How to understand this? See, if you are standing on a lower window, you need to move my head more compared to when you are standing on this upper window. Okay, because the level difference between the upper window and the balloon is less compared to the level difference between the lower window and the balloon. Okay, this much is the level difference between the lower window and the balloon, and only this much is the level difference between upper window and the balloon. So definitely where the level difference is more, the angle of elevation will be more. So I can conclude that this angle has to be 60 degrees and definitely this angle has to be 30 degrees. Okay, this angle is 30 degrees. Now, so this is what we have concluded. Now what is our task? Our task is to find the height of the balloon above the ground. So by how much length the balloon is above the ground level. So to find, my task is to find the length of DE. Okay, because DE represents the height of balloon above the ground level. Now you can see that this DE line is in three parts. It is made up of three parts. I can write DE is equals to DG plus GF plus FE. Okay. Now you can see this AF represents a horizontal line drawn from this A point. So AB and this FE both are equal. This is 2 meters, so definitely this is also 2 meters. Okay, so I have the value of FE as 2 meters. Then what about the value of DG and GF? So if somehow I calculate the value of DG and GF, I will be able to determine the length of DE, okay, or I will be able to determine the height of balloon. So my approach should be what? It should be to determine the length of DG and GF. If somehow I determine the lengths of DG and GF, I will definitely get the value of DE. Okay. So for further observation, if I observe very carefully one more time, I can see this AFGC. This AFGC is also a rectangle. Okay. Now since it is a rectangle, so the length of AC and length of FG must be equal. So this is 4 meter. So definitely I can say that this FG is also 4 meters. So I have the length of this GF as 4 meters. So now I have two values, GF and FE. Now only task left is to determine the value of DG. What is DG? This represents DG. So how to determine the length of this value, length of this DG? Let us try to solve this. I can see that I have drawn the diagram, I have identified the unknown quantity as well. Our actual unknown quantity is this, and by interpretation we have determined, we have got that dg is actually a known quantity. So if I calculate the length of dg, my question is solved. So now we have observed the diagram. Now next task is to determine the right angled triangles. And remember, which right angled triangles? Those right angled triangles which contains the given angles, that is the angle of depression or angle of elevation or whatever. So I can see 30 degree and 60 degree are the given angles. So based on these two angles, I can write there are two right angled triangles. First triangle is CDG, and another triangle is triangle ADF. So I have these two triangles, CDG, CDG and ADF. This is ADF. Okay. Now I can see that in both the triangles, what is the similarity, what is the common thing between the two triangles? I can see this CG and AF, both are equal. Why? Because the diagram looks like this. This is a vertical lines and this is our horizontal lines. So this is a rectangle. That's why CG and AF both are equal. The value of CG and AF both are equal. So I will relate these two triangles using this condition. Okay. Now observe the triangle CDG. In triangle CDG, this angle is 30 degree. With respect to this angle, DG represents perpendicular and CG represents base. So my task is to determine the length of DG. Okay, that's why I will determine the trigonometric ratio tan. Okay, tan 30 degree. Tan 30 degree is perpendicular upon base. Perpendicular is DG, upon base is CG. So what is tan 30 degree? It is 1 upon root 3. So you will get CG is equals to DG root 3. This is the length of CD. Okay, sorry, not CD, it is CG. Now try to understand why I have taken tan of 30 degree. It's because DG is the quantity which is need to be determined and CG is the quantity which relates both the triangles. That's why I have used CG. Now observe the second triangle, triangle ADF. In triangle ADF, this angle is 60 degree. This DF is perpendicular with respect to this angle and this AF is base with respect to this 60 degree. So I can write tan of angle 60 degree is equals to DF upon AF. Now why I have used tan of 60 degree? It's because if tan of 60 degree, it contains this perpendicular and in perpendicular I have this DG as unknown quantity. मुझे ये साफ दिख रहा है कि DG जो कि unknown quantity है वो उस triangle के perpendicular में lie कर रही है. And one more thing, AF की जब हम बात करें तो AF क्या है? AF वह साइड है जिससे कि हम दोनों ट्राइंगल्स को रिलेट कर सकते हैं. Why? Because AF और CG बराबर है. That's why यहाँ पर हमने tan 60 डिग्री लिया where it is equal to DF upon AF. And what is DF? In place of DF I can write DG plus FG. So this is DG plus GF upon AF as it is, or in place of AF I can write CG. So what is GF? GF is 4 meters. So I can write DG plus 4 upon CG. So from here I will get the value of CG is equals to DG plus 4 upon root 3. Okay, this is the value of CG. Now observe this. This is, let us say, the first equation. This is, let us say, the second equation. And if I compare the two equations, both the equations contain CG in their LHS. That's why I can directly write DG root 3 is equals to DG plus 4 upon root 3. So this will give you When you multiply this root 3, it will become 3 dg, and 3 dg minus dg will give you 2 dg is equals to 4, and the length of dg is 2 meters. Okay, so finally I have the length of dg as 2 meters, and from here I can write the length of de as 2 plus 4 plus 2, that is 8 meters. So 8 meters is the height of balloon above the ground level. Okay. So this question is very interesting question. You can see it do not contain huge calculations, but it has some interesting concepts. Okay. It has some identification property, identification skills that you can develop in this chapter. This triangle, you can see there are multiple triangles available in this particular diagram, but still why I have chosen only these two triangles, that must be clear to you. Okay. So what I told you, it's because this triangle contains 30-degree angle which is given, that is the angle of elevation, and this angle also contains the angle of elevation. That's why I have chosen both the triangles. Now from this I have determined the tan ratio, and also you need to know why I have determined the tan ratios. Why not sine ratio, why not cos ratio, or why not cosec or sec or cot ratio? It's because tan ratio relates perpendicular and base. My base is common for both the triangles, the length of base is equal, and the second thing, the perpendiculars in both the triangles contains the unknown quantity. Okay, that's why I have used tan of angles elevation. Okay, tangent of these angles. So in this manner you need to solve question number 28. It's very interesting, low calculation, high IQ. Okay, you need to put your mind in this question. So you can note this, then we will continue. Okay, let us now solve question number 29 from the practice sheet. Question number 29 says, the elevation of a tower at a station A due north of it is alpha, and at a station B due east of A is beta. Prove that the height of the tower is d times sine alpha into sine beta upon root of sine square alpha minus sine square beta, where AB is equal to D. Okay, so let us try to analyze the question, let us try to understand it line by line. It says the angle of elevation of a tower at a station B. So it means I am observing a tower from a station at a station A. It means I am observing the tower from a station which is named as A, and this station is due north of it. Due north of it means that the station A is located in the north direction of tower. So for that, let us first make a standard of directions. Which direction should I use? I am using this convention that this is east, this is west, this is north, and this is south. Okay, I assume that these are the four directions: east in this side, okay, west there, and north in upwards and south in downwards. So this is what my assumption is. Now further, for that let us draw a tower. So there is a tower, let us say this is the ground level. Okay, on this ground level there is a tower. Let us say this is the tower, this CD represents a tower, and due north of this tower. Now you can see that if tower is located at this point, okay, if I observe the tower from the top, okay, from the top, what I will see is that this is the position where the tower is located. Okay, this is CD. Okay, try to understand, I am observing this tower from the top. Okay, I am in a helicopter and I am observing this tower from the top. I observe that there is a point A which is in the north direction. You can see this is the north direction. So if this is the tower from the top, I can see this is the north direction, and this is the point A located in the north direction. What it says is the elevation of a tower at a station A due north of it is alpha. So if I observe this as A point, then this will be the line of sight. Now if I am observing this tower from the top, I will not be able to visualize what should be the angle of elevation. For observing the angle of elevation, I need to assume the tower in this manner, that is, I need to have a side view of the tower. So this is, let us say, the side view. Let us say I am observing the tower from this direction. So this is the side view, okay, and this is the point A located somewhere here. The angle of elevation of the top of the tower. So this is my line of sight, and this angle is given as alpha. Okay, this angle is given as alpha. Now further, and at a station B due east of A. So there is one more station B which is located in the east of A, not east of tower, it is located in the east of A. Where is A point? This is the station A. What is the east of this station? East of this station, I can see east is this direction, so definitely I need to move in this direction to locate the point B or the station B. So this is the station B, this is the station given as B. Try to remember, I am observing this tower, this diagram in a helicopter and from the top. So from the top, the tower will look like a point, the station will look like a point. This is the north direction, this is the east direction. So if I observe this tower from this B station, this will be my line of sight. Now again, it will be difficult for me to visualize the angle of elevation from the top view. For that I need the side view. So let us try to draw the side view on this diagram only. Okay, let us try to visualize the side view. What I can draw is, I can draw a line from this A point like this, okay, that is in a 3D. This A point is, this C point, B point lies like this, perpendicular to this A point, okay. So it is lying somewhere here. If this is the plane, then this is the C point, B point where it is lying, okay. It is east of point A. So this is the point A and this is the point B. I can mark this point here, okay, and from this point I am observing the top of this tower. So to draw this B point on the plane, on this plane in a 3D view, I can draw it like this, okay, and this is the angle of elevation. This is the point B, this is BD, this is the foot of the tower, and remember this angle is 90 degrees. What I have done is, this B point should lie outside this board, but I cannot draw a 3D figure on this board because this board is a 2-dimensional, it is a 2D. So what I have done is, I have tilted this B point, okay, I have tried to visualize this B point here and said that let us say this angle is 90 degree. In actual, B point is in this plane, okay, it is away from the board, outside the board, somewhere here. So from this point I am observing the top of this tower. So the angle between this AD and this AB, this AD, this is the foot of the tower, C and D, top and foot, this AD and this AB is 90 degrees, because this B point is exactly in the east of this point A. That's why I have made this angle as 90 degrees. Now the angle of elevation of this point from this B point is this one, and this angle is beta. This angle is given as beta, okay. So further it says, prove that the height of the tower. What is the tower? This CD represents the height. Height of the tower is d times sine alpha sine beta upon square root of sine square alpha minus sine square beta. So to prove is, so my task is to prove CD, which is the height of tower, it is d times sin alpha into sin beta upon square root of sin square alpha minus sin square beta. This is the CD or the height of the tower, and where AB is equal to D, where this D represents the distance between A and B. This is given as D. Okay, this AB, this length is given as D. So this is a 3D diagram. This is not a 2-dimensional diagram, it's a 3-dimensional diagram. I have drawn this diagram twice for the convenience that this is the side view of the diagram. If I observe the figure, if I observe this diagram from the side, I will be able to visualize this, and this is the top view. I am observing this diagram from a helicopter. Okay, this is the tower, this is the station A, this is the station B. So this is the position of all these three, tower and the station. Now my task is to prove the height of the tower. This height of the tower, it is given as D times sin alpha sin beta. So what I can observe is that in the given diagram I know what is sin alpha, I know what is alpha and I know what is beta. So our proof requires us to determine the value of sin alpha. Okay, that is the sine trigonometric ratio of alpha and beta. So let us try to visualize this condition only. Okay, first of all, let us try to determine the right angled triangles. What kind of right angled triangles you can observe? If I observe from the side view, I can see this ADC is a right angled triangle. Okay, and this BDC is also a right angled triangle, because remember B point is not like below A point, it is like this, it is in 3 dimension. So I have drawn it here, it is in 3 dimension in this plane, somewhere here, B point is somewhere here. From this point I am observing the top of this tower. So definitely BDC, it has to be a right angled triangle because this tower is perpendicular to the ground. Okay, and if I observe from the top view, if I observe the same situation from the top view, I will be able to see that ADB represents one more right angled triangle. Okay, why D? Because D is the foot of the tower and A and B also lie on the ground. So DAB, it also represents a right angled triangle. So now our task is to prove the height of this tower as equal to some big value. So what we will do, what should be our approach? Our approach will be to solve the RHS of this condition and make it equal to CD. Okay, what I am going to do is I am going to solve this RHS and I am going to make it equal to CD. Okay, I will prove that while solving this RHS you will get finally CD. Okay, just as you have done in trigonometric questions. Okay, so what I am going to do is I will write RHS is equals to what? It is D times sin alpha into sin beta upon square root of sin square alpha minus sin square beta. So what I can see is RHS contains sine of angle alpha and beta. So my task is first to determine the value of sine of alpha and sine of beta. What is alpha? This is alpha and it lies in the triangle ACD. So with respect to this alpha, CD represents the perpendicular and AC represents the base. So I can write that sine of angle alpha is equals to CD upon AC. Okay, CD upon AC. Similarly, if I observe the triangle BDC, okay, remember B point is outside the board, so BDC is also a right angled triangle. So that's why this is the right angled triangle. Okay, that's why I can write sine of beta is equals to what? This is beta. With respect to this beta, this CD is the perpendicular and this BC is the base. So this is CD upon BC. I can write this as CD upon BC. Okay. So let us solve this. Let us substitute the value of sin alpha and sin beta in this given condition. So this will give you d times sin alpha is CD upon AC into sin beta is CD upon BC upon square root of CD upon AC square minus CD upon BC square. Okay, this is what I can write. Now simplifying this will give you d into CD upon AC times CD upon AC whole upon, now you will take CD as common, so CD square will come out in the square root, and when you square root CD square it will give you CD. So CD will finally come out, and in the bracket you will be left with square root of BC square minus AC square upon BC, sorry this is BC into AC. Okay, this is what you will get. You just solve this condition, you will take CD square as common, and in bracket you will be left with 1 upon AC square minus 1 upon BC square. Then I just cross multiplied and finally I will get this condition. This AC square when square rooted it will become AC, and this BC square when square rooted it will become BC. So you will get this condition. Now further I can cancel this CD and CD. I will be left with D into CD upon AC into BC into AC into BC upon square root of BC square minus AC square. This is what I will get. I can cancel this AC BC and AC BC, and I will be left with D times CD upon square root of BC square minus AC square. Okay. Now my task is to prove this condition equal to CD. Okay. It means somehow I need to eliminate this D and this BC square and AC square. So if I observe this diagram, what is AC? AC is the hypotenuse of triangle ACD. So AC square is definitely equal to this. AC square is the hypotenuse of triangle ACD. So AC square is definitely equal to CD square plus AD square. This is what AC square is. Okay. Similarly, if you observe BC square, BC is the hypotenuse of triangle BCD of this right angle triangle. So BC square is equals to CD square plus BD square. So CD square plus BD square is equals to BC square. This is what I can get by using Pythagoras theorem. So in place of AC square I can write CD square plus AD square, and in place of BC square I can write CD square plus BD square. So from here I will get, so let us move it here. From here I will get, it is equivalent to D times CD upon, now first is BC square. So in place of BC square I can write CD square plus BD square. So square root of CD square plus BD square minus, next is AC square. AC square is CD square plus AD square. So this will give you CD square plus AD square. Now further you will get D times CD upon, now you can see when you open the brackets this CD square and CD square will get cancelled, and in bracket you will be left with BD square minus AD square. Okay, BD square minus AD square. Now what is BD square minus AD square? I can see in this triangle it is difficult, in this figure it is difficult to identify BD square and AD square. So if I observe this triangle, this figure, that is the top view, I can see this is also a right angle triangle and this BD represents the hypotenuse. So from here I can write BD square is equals to what? It is AB square plus AD square. So it implies BD square minus AD square will be what? It will be AB square. So it will be BD square minus AD square, it is equals to AB square. So in place of BD square minus AB square, AD square, I can write AB square. So this will give you D into CD upon square root of AB square, which is equals to D into CD upon AB. Now what is AB? AB is given as D. So in place of AB I can write D. So this will give you D times CD upon D, and when you cancel these values you will be left with CD, and this CD is the RHS. This is the right hypotenuse side. Okay, sorry, not right hypotenuse side, it is the right hand side of this equation. So what we have done is, we have proved that this condition, this value represents CD, and CD is what? CD is the height of the tower. That's why I have proved that the height of the tower is equals to D times sin alpha sin beta upon square root of sin square alpha minus sin square beta. Okay. So again, you need to understand what I have applied. I thought that I have sin alpha and sin beta, so why not use sin alpha and sin beta only? I have identified the value of sin alpha sin beta, and simple the application of Pythagoras theorem, I will get the final result. This is the result. Okay. So you can see this question is not at all difficult, only the tricky part is the 3D diagram. Okay. This diagram is in 3 dimension, this is the top view, this is the side view. Okay. So this is the solution for question number 29. It's very interesting question and also a very high level question. Okay, so you note this.